Hello friends, welcome to Study Spectrum, welcome to 9 CBSE and welcome to the very first chapter of science, that is matter in our surroundings. Now what we are going to study in this chapter, let us talk about that first. We will try to introduce matter first, that is the very first topic will be introduction of matter. Second, what are the physical properties of matter? Third, what are the characteristics of particles because of which a matter is made up of? Fourth, what are the different states of matter? Fifth, can matter change its state? And sixth, we'll talk about a process where a matter can change its state, that is evaporation. And we'll try to learn what is evaporation, what happens when evaporation takes place. And obviously we know when liquid state changes into gaseous state, then the process is called as evaporation. So these are the 6 topics which we are going to cover in this chapter. Now, let us talk about matter. Friends, if in this surroundings, in our day-to-day life, in surroundings, if we see many objects, things, correct, which are made up of some material which scientists named as matter, correct. It doesn't matter if you see on this planet, galaxy, universe, anywhere. They have different shapes, they have different sizes and different textures. They are made up of some material which scientists have named as matter. Correct? The air we breathe, the food we eat, stones, clouds, fire, mountains, trees, plants, animals, even a drop of water and even a sand particle is made up of matter. Right? Now the point to be noted is, as we look around in our surroundings, these objects, these things occupy some or the other space. It means if we want to define matter, how we can define matter? Matter is something which occupies volume and also has some mass. Anything which occupies some volume and has some mass is termed as matter. Now friends, right from the very early beginning, when human beings came into existence, they always had explored surroundings and wanted to figure out what is surrounding made up of. Correct? Now in early age, Indian philosophers, every Indian philosophers classified matter into 5 elements. In Hindi it was termed as Panch Tattva. Panch means 5, Tattva means elements. So they classified matter into 5 elements, that is Panch Tattva in Hindi, and these elements were air, earth, fire, sky and water. Air, earth, fire, sky and water. They said, and according to them, all living things and non-living things are made up of at least each or combination of these elements, these 5 tattva, 5 elements. Even at later stage, ancient Greek philosophers also classified matter on the same basis. They also agreed. In modern scenario, scientists have classified matter in 2 categories and on the basis of physical properties and chemical natures. It means modern scientists have classified matter on the basis of 2 factors, that is physical properties and chemical nature. Now after introduction of matter, let us talk about physical properties of matter. Matter is made up of particles. But friends, over a long period of time, there was 2 schools of thoughts, or people thought in 2 different ways. One school of thought said matter is a continuous thing, like a piece of wood. A piece of wood is a continuous thing. Whereas the other school of thought said a matter is made up of particles like sand. If you take too many particles of n number of particles of a sand, it will make a regular shape or a body and can be termed as that particular body is made up of different particles of sand. So one school of thought was matter is continuous, the other school of thought was matter is made up of particles. Now let us understand which school of thought was right or is right or should be right. Let us understand this through an activity. Suppose I have a beaker of water, correct? You take a crystal clear made up of glass, a beaker of water filled with water. You pour some salt into it, solid particles of salt into it. Now obviously you can see the small particles of salt, and you have dissolved so n number of salt particles into that beaker which contains water. Now what happens as you mix salt into that water and mix it thoroughly, slowly and slowly salt starts to disappear, correct? I hope you appreciate it. If you take a glass of water and if you dissolve salt into it, slowly and slowly you will realize that salt is disappearing. Now where these salt particles have disappeared? They do exist in the liquid or they have vanished? The answer is, the explanation is, actually what happens, we cannot see the very small particles of salt. What we see is a cluster of n number of very fine particles which becomes a very small cube of salt. But when we dissolve that salt into water, that small block of salt splits into n number of molecules of that salt or atoms of salt, but it should be molecules because we are talking about salt. So it splits up into n number of molecules of salt, and they are occupied in the gaps between two water molecules or n number of water molecules. Okay, now what happens, that salt is disappearing just because the salt particles, the very fine minute salt particles, are actually trapped into the water molecules of that liquid contained in that beaker. Now it illustrates, it helps us to understand that actually a matter is made up of particles. Why? Because if you have tasted that water, the taste will be normal taste of water. But after you mix salt into it, the salt doesn't vanish or disappear from that solution. It actually gets trapped into the water molecules between the pores, the holes in water molecules, and that is why the taste becomes salty. It means that solution do contains salt, and it also tells us that matter or that salt in particular was made up of particles, and those particles separates out from each other, gets trapped into water molecules. So this examples, this activity tells us that actually matter is made up of particles. Now the second point is how fine these particles are. That is, how small these particles are of matter. The second physical property which we are going to see after we have understood that matter is made up of particles, the second physical property which we are going to see is how fine these particles can be, or how small these particles of matter are or can be. Let us understand this point also with the help of an activity or an example. Suppose I take hydrous or copper sulfate, you can just call it as copper sulfate also, or hydrated copper sulfate also. Suppose I take 2-3 crystals of, or say 2-3 gram of copper sulfate and dissolve it into 100 ml of water into a beaker, correct? You can see that color has to be pure blue color of the solution. Once you mix that copper sulfate into 100 ml of water, you can see the color of the solution as blue. Now what you do is, you take 10 ml of that solution and pour into another beaker containing 90 ml of water, correct? You take 10 ml of copper sulfate solution from the very first copper sulfate solution and pour it into another beaker containing pure water but 90 ml. Now just assume the water to be as 100 ml in the second beaker. What change you figure out? The change you figure out is, in the first beaker blue color was very good. I mean, it was not fine, it was a dark blue color. But in the second beaker, when you took out 10 ml from the first beaker and pour it into the second beaker containing 90 ml of water, you find that the color fades a little bit. Now you take 10 ml from the second beaker. The second beaker is also now solution of copper sulfate, which is light blue in color. You take 10 ml from that second beaker and pour it into 90 ml of water into third beaker. The third beaker also now has 100 ml of copper sulfate solution, but the color has faded more. The blue color of the solution has faded more than the first beaker. You take 10 ml from the third beaker. That beaker is also a solution of copper sulfate. You take 10 ml from the third beaker and pour it into the fourth beaker. Now what you figure out? You will figure out the color has faded too much. It has become very light blue color solution of copper sulfate. But the point to be noted is it is still a copper sulfate solution. Now you have 4 different beakers of copper sulfate solution. The very first beaker is having good blue color solution, correct? The second beaker has blue color solution but faded a little bit from the very first beaker. The third beaker is more faded and the fourth beaker is highly faded. Now the important point to note is every single beaker is containing copper sulfate solution. There is visibility of blue color but very less in the fourth beaker than in third, than in second, than in first. It means the size of particle cannot be imagined. It is beyond our imagination. When concentration of copper sulfate in the first solution was more, the color was bright. When it was reduced, the color faded. When it was further reduced, the color further faded, and when it was brought into the fourth beaker containing 90 ml of water, it faded very much. But still there is visibility, and if there is visibility of blue color, doesn't matter very less or bright, if there is visibility of blue color, then it tells us that it do contains copper sulfate particles. Now what we can figure out from these 4 beakers? We can figure out from these 4 beakers is that you cannot imagine the size of a particle. It is beyond our imagination, correct? So if you want to elaborate, if you want to illustrate how fine the particles of a matter it can be, or how small the particles of a matter can be, you cannot imagine. That is beyond our imagination. It can be very fine. It can be in terms of centimeters also. It can be in terms of millimeters also. It can be in terms of micrometers also. It can be in terms of nanometers also. It can be in terms of picometers also, and it can be in terms of fermimeter also. Now I have taken so many units, names of so many units, but what are these units? Centimeters obviously you know, millimeter obviously you know, you can see on your ruler scale also. Micrometer means 10 to the power of minus 6 meter. Nanometer means nm. Nanometer means 10 to the power of minus 9 meter. Picometer pm. Picometer means 10 to the power of minus 12 meters. And fermimeter fm means 10 to the power of minus 15 meters. 10 to the power of minus 15 meters. Just imagine how small that size is. That is why we cannot imagine how smaller, how fine a particle of a matter can be. That was the second property, physical property of matter. So the 2 properties, physical properties of matter just we have seen are, matters are made up of particles, first property, and the second property is these particles can be very fine, or how small these particles of matter can be, which we have just elaborated with an example. These particles keeps on dividing themselves. These particles keeps on dividing themselves into tiny species or particles, subparticles. That is why that color faded but did not vanished. Had this color been vanished, then we could have said there is no, even a single particle of copper sulfate in that solution. Now, let us talk about the characteristics of particles. The very first characteristic of particle is these particles have spaces between them. How? We have just taken the example of copper sulfate. Let us take some different example. For example, You might have seen, if you take a cup of boiled water, you have boiled water into a cup, and you have a tea bag or coffee. Let us assume we have a tea bag. If you dip that tea bag and move it into the that boiled water in that cup, what will happen? You will find slowly that color of tea will spread uniformly throughout the volume of that boiled water. It means it reflects that those particles containing in a tea bag are actually being trapped into the molecules of water. It means, or it reflects, that molecules of water do have spaces between them. We have taken the example of copper sulfate earlier also, while we have talked about physical property of matter, how small, how fine the particles of matter can be. If you dissolve few crystals of copper sulfate into water, it will slowly change the color of whole of the volume of water as blue. It means particles of copper sulfate are dividing into n number of tiny particles and being trapped into molecules of water. Also, if you dissolve coffee into, say, cup of milk, you will see slowly the color changes to brown color of coffee. It means those particles are being trapped or are being placed in between the molecules of water. Now, these examples actually illustrate us that there are lots of spaces between particles of a matter. You take any example, say salt. If you take, say, Glucon-D also, you might have seen originally the color of Glucon-D is white, but when you mix it into a volume of water, then what happens? The color changes, and the color is not like it is orange at the top, white in the middle, or colorless at the bottom. It is throughout the same color. Doesn't matter orange or white or grey, whatever the color is, but it will be uniform throughout the volume. It means the particles of Glucon-D or any substance which is being dissolved in water or any other solvent is being trapped or is being placed between the molecules of that particular solvent. It tells us that particles do have spaces between them.
No more spending your energy and money on coaching classes or missing classes for rain, for rally, and any other nonsense. Subjects covered by multiple teachers with repeat telecasts. Doubts, concepts, applications, no problem. All explained through great and significant animation. So sit back comfortably in your home and watch Study Spectrum TV channel.
So it tells us that particles of one type of matter get into the spaces or space between the particles of the other type of matter. Like, for example, dissolution of tea, dissolution of coffee into milk, or lemonade into water, whatever example you take. It tells us that particles of one type of matter get into the spaces of particles of the other type of matter. Now let us talk about the second characteristics of particles of matter. These particles are continuously moving is the second characteristics of particles of matter. Now let us understand how these particles are continuously moving. Now suppose we take a room, you take any room in your house or classroom even, you stick an unlit incense stick, that is agarbatti. You stick an unlit incense stick at one corner and you observe how close you have to get to the stick to smell it. How close you can get to the stick to smell it. And second thing you do is you light up that incense stick. Okay? And then you stand on the other corner and see or try to smell how fast that smell reaches to you, or how fast you can smell that fragrance of that incense stick. Now, since you can smell that fragrance stick in few seconds or few minutes, maybe what the time can be anything depending on the area of the room. So, it tells us that fragrance or that particles are actually moving into air. They are being trapped, they are getting into the space of the particles of air, and also they are continuously moving, because if they don't travel, if they don't move, they will not reach to your nose, you cannot smell it. Correct? So it means if those particles of burning incense stick, the smoke or the gas which comes out from that burnt incense stick is actually moving, traveling, those particles are traveling in there. That is why you can smell it on the other corner also, or even at any point in the room. Correct? So this is an example which illustrates, which tells us that particles of a matter are continuously moving. Also, if you take another example, say you have a beaker filled with glass. Okay, the beaker is filled with some volume of water. You drop 1 ml of ink into it. You can see the movement of ink particles. Slowly, gradually, the whole of the volume of water will convert into blue color. That ink is blue. If the ink is blue, that volume will convert into blue color. Now you can see the movement of that blue color, how it travels from the surface to the bottom of that beaker. You can see the spreading up of the particles of that ink. It tells us that it is showing the first property. It is showing the first property that particles, particles of one type of matter get into spaces of particles of the other type of matter. It also tells us that particles are moving, continuously moving. Correct? So this was the second example. Now let us talk about some more examples which will help us to understand the second characteristics of particles of matter, that is, particles are continuously moving in space or in the medium of other particles. Now let us take another example. You take two beakers made up of glass, similar type of beakers. You pour some volume of cold water into one beaker. You pour same volume of water but hot in the other beaker. So one beaker contains volume but some volume of water but cold. The other beaker contains same volume of water but hot. Now you drop say 2 grams of hydrated copper sulfate crystals into each beaker. Slowly you observe how quickly or how slowly that blue color of copper sulfate gets diffused into the whole of the volume of water in each beaker. I'm sure you will find or you'll see or you'll observe rather that the beaker which contains hot water, in that particular case the blue color spreads out more faster than the beaker which contains cold water. Now since the second property says particles of matter are continuously moving, and we understand if something is moving it should have velocity. Now we have already studied, we have already learned that particles matter occupies space or occupies some volume but also has mass. Now these particles are moving, that is a characteristic of the particle. These particles are moving, they do have mass also, it means they will have kinetic energy also. Correct? Now this kinetic energy is actually responsible for the movement of these particles. Now from the last activity, that is two beakers containing equal volumes of cold water and hot water in two different beakers, and we pour 2 grams of hydrated copper sulfate crystals into it. We observe that in hot water the movement of particles of copper sulfate was faster than in cold water. It tells us that as we raise the temperature, the kinetic energy of molecules or particles of matter increases. That is why when the kinetic energy increases, the velocity increases and they quickly move throughout the volume or they quickly diffuse into the volume, then in that case where the temperature was low. So it means the particles are moving continuously. Since they are moving, they should possess kinetic energy, and this kinetic energy is actually responsible for them moving continuously throughout the volume in this particular case and in every case also. As you raise the temperature, kinetic energy increases and the movement becomes faster. Correct? So what we have learned? We have learned physical properties of matter. That is, matter is made up of particles. If you remember, if you recall, there were two school of thoughts. One said matter is a continuous thing like a piece of wood. The other said matter is made up of particles like particles of sand. And we have illustrated an example also for that, for a justification. The second physical property was that particles can be very fine also. They divide themselves into n number of finest particles, and the size of particles we cannot imagine, that is beyond our imagination. Correct? If you remember, we have taken the example of copper sulfate solution. We dilute, we keep on diluting the solution and we see that the color is there, no matter it has faded, but still we can see the color. And if we can see the color, the particles are present. Correct? And we have talked about characteristics of particles also. Particles have space between them. That is why particles of one type of matter get into space between the particles of other type of matter. That is, for example, a dissolution of tea into water, dissolution of coffee into milk, or lemonade into water. We have seen that. And just now we have understood that the particles are continuously moving, and since they are moving, they possess kinetic energy, and this kinetic energy increases with the increase in temperature. That is why the process diffusion, the rate of diffusion also increases as we increase the temperature.